Arbitrum is an EVM-compatible layer 2 network that scales Ethereum using the optimistic rollup technique. We'll dissect each keyword one by one, but before that we need to understand why we even need Arbitrum. So we need a solution to scale Ethereum that would increase the throughput of the network, that is facilitate a higher number of transactions per second, and also reduce the cost of doing any activity on the network. There exist multiple solutions that help with this, and Arbitrum is one of those solutions. Ethereum is the world computer. Unlike a general system where state and computation happens on a single system and is controlled by a single entity, state and computation on Ethereum is maintained by a distributed network of computers, and all of the state changes are recorded using a blockchain. And because of this, we have a scaling problem on Ethereum. So we have a limited resource called block space. Generally, block space is the maximum amount of data you can store in a single block. But since Ethereum is a global computer, block space on Ethereum is the maximum amount of computations you can do in a single block. Or simply put, the maximum amount of state changes you can record in a single block. So as of now, one block can facilitate a maximum of 45 million gas. Remember that each computation on Ethereum is measured in gas. So if you do an addition operation, it would cost you some gas. If you do a subtraction operation, it would cost you some gas. And by putting a limit on the total amount of computation you can do on a single block, Ethereum basically limits the activity or the throughput happening on the network. Apart from this, base fee also adjusts dynamically based on the block space usage. So the more block space is being used, the more demand there is, and the more scarcity of computational resources would be there. And by the general laws of supply and demand, the price of doing any activity on Ethereum increases. Hence, during the times of network congestion, the network almost becomes unusable because of its high cost. Now, if block space is the problem, why don't we simply increase it? For that, you would need to understand the scalability trilemma. Scalability trilemma states that at any given point in time, it's very difficult for a blockchain to achieve all of these three properties, which are decentralization, security, and scalability. Decentralization means that anybody can participate in running and maintaining the network, and no single entity is controlling the network. Security means the ledger's ability to prevent any kind of attacks or ledger manipulation, and scalability means the network's throughput. If we were to increase the block space, we'll get more scalability for sure. We'll be able to do more transactions and get a higher throughput from the network. But because of this, decentralization would also suffer. More throughput would mean that we would need to do more computations per block, which means that each node would need a higher processing power, which would create a barrier to entry for running and maintaining the network, and the network would be controlled by fewer amount of nodes. And because of this, the security of the network would also suffer, because fewer nodes maintaining the network means that the network is easy to attack and manipulate. So what can we do? We have a few possible solutions. One is on-chain scaling, where we upgrade the base Ethereum layer, but that is a very long and complex process. It has already been going on for a few years and it will take a few more years to complete. The other solution we have is off-chain scaling, where we build some solutions outside the Ethereum network and they settle on the Ethereum network. These are called layer 2 networks. So scaling Ethereum becomes a long process where we are upgrading the base Ethereum layer, that is Ethereum goes from Ethereum to Ethereum 2.0, which is much more efficient than the current version of Ethereum. And we are also building layer 2 networks that are settling on Ethereum. And over a timeline, you would see both of these evolving parallelly, and the result would be an upgraded base Ethereum layer, which is much more efficient and will also have a vibrant ecosystem of different kind of layer 2 networks settling on Ethereum. So we'll have a compounding effect of both of these solutions. You can think of these layer 2 networks as faster roads to a highway that Ethereum is. There are many kind of layer 2 networks like roll-up, state channels, plasma, and Validium. Since Arbitrum is a roll-up network, we'll discuss only roll-ups in this video. So roll-up networks execute the transactions on their own. They have a separate state from the Ethereum and they execute the transaction on their own chain, and they post the transaction data or some kind of proof of correctness of transactions on the layer 1 chain, which is Ethereum, for verification and validation. Ethereum, or the layer 1 chain, acts as a security layer or the settlement layer that ensures the integrity of the layer 2 state. Optimistic rollup are one kind of rollups where It is assumed that the transactions are correct. If somebody disagrees, then they can prove otherwise. Arbitrum and optimism are the most prominent examples of optimistic rollup. They follow the same fundamental thought process, but the exact technical approach differs slightly. There is a difference on how transactions execute on Arbitrum versus Ethereum. On Ethereum, a user sends a transaction to the Ethereum network. A node picks it up, verifies the transaction, and validates it, and then adds the transaction in a block along with other transactions for execution. The block is then broadcasted to other nodes of the network, and each node would verify and validate the transactions of the block on their own system. If the nodes arrive at a consensus, the block is approved and added to the Ethereum network. Arbitrum, on the other hand, has a slightly longer transaction lifecycle. A user sends a transaction to the Arbitrum network. The transaction goes to a component called sequencer on Arbitrum. The sequencer or the Arbitrum network assumes that the transaction is valid. They don't verify it. The sequencer then orders the transactions in batches and it compresses and soft commit the batch on the layer 1 network, that is Ethereum. This is called as soft finality. So you have an idea of which transactions are going to execute in which order, and you can guess what the state would be after the execution of those transactions. The transactions are then executed on layer 2 network, and the final transaction data of L2 block is compressed and sent to the layer 1 network. Using the transaction data posted on layer 1 network, any Arbitrum validator can detect and challenge a fraud transaction. The disputed transaction is then verified using a fraud detection mechanism. If the transaction is found to be fraud, the block is discarded and the validator that added that transaction is penalized. The transaction is considered to be final if it goes undisputed during a challenge window, which usually lasts a week or 7 days. This is called as hard finality. This entire process solves Ethereum's scaling process by executing transactions off chain and verifying them on chain. So multiple transactions are executed off chain on the layer 2 network, and the transaction data is then posted on Ethereum for final verification. Doing this doesn't use Ethereum's computational resources. This basically increases the overall throughput of Ethereum network because Ethereum only has to process a few transactions that verify and validate the state of L2. So when there are thousands of transactions happening on the layer 2 network, Ethereum just verifies them using a few transactions on its own network. This also reduces the cost of doing activity because the gas we used for Ethereum transaction gets divided among all of the transactions in the L2 batch. And Arbitrum also is a stack of software that helps you deploy your own customized rollup chain. So Arbitrum 1 is the layer 2 chain deployed on Ethereum by Arbitrum Foundation, but you can also use the Arbitrum stack to spin up your own customized rollup chain and deploy it on Ethereum. These chains are called orbit chains. You can also use the Arbitrum stack to deploy customized layer 3 chains on Arbitrum or any other orbit chain. And Arbitrum also has a variant called AnyTrust. So Arbitrum Nova is deployed using the AnyTrust protocol, which basically ditches Ethereum in favor of a data availability committee to reduce cost. Ethereum is used as a fallback mechanism just in case DAC is not available. Arbitrum is EVM compatible, which means any dApp that you would deploy on Ethereum, you can also deploy on Arbitrum without any changes. It facilitates a higher throughput and lowers the transaction cost, and also gives you a modular stack that can help you in deploying your own customized chain, but it has its own limitations. Currently, the sequencer of Arbitrum is centralized, so there's only one sequencer on an Arbitrum chain, and on the main Arbitrum chain, that is Arbitrum 1, it is being run by off-chain labs. There are plans to decentralize the sequencer in future, but we'll see it when we get there. So that was Arbitrum in a nutshell. You can ask any doubt, any queries in the comment. You can also suggest a topic that you'd like to know more about in the comment section. Subscribe for more such videos and like and share for good karma. Remember that nothing in this video is a financial advice and you have to do your own research.